So we've said that buffered solutions resist changes in pH when we add a strong acid or a strong base. Let's take a look at this. Let's compare what happens when we add the same amount of strong acid to water and then to a buffer. So to start with, water has a pH of 7. What happens when 0.2 moles of HCl is added to enough water to form 500 milliliters of solution? Okay, so the first thing we're going to do is go ahead and find the concentration of the H+. So H+ is going to equal your moles of HCl, so 0.2 moles over 0.5 liters, and you've got 0.4 molar H+. If we take the minus the log of that, we'll get the pH as 0.398. So when we added 0.2 moles of HCl to water, the pH went all the way from 7 down to 0.398. That's a pretty drastic drop. Let's see what happens when we add that same amount of HCl to a buffered solution, a solution that is going to have some acetic acid and some sodium acetate. So first, look and see what the pH of the original buffer would be before we add any HCl, so we can see how much it's changing. Okay, so our original buffer is 0.5 moles of HAC and 0.5 moles of that. So H+ is Ka, moles of acid over moles of base, 1.8 times 10 to the minus 5 molar H+. If we take the minus the log of that, we get pH is 4.745. So that's what the pH is of our buffer before we add any HCl. So now what's going to happen when we add the HCl? Is the HCl going to react with the acid part of the buffer or the base part of the buffer? Well, obviously acids react with bases. So the H+ is going to react with the acetate to make some more acetic acid. So we're going to find that when we're done, we have a little less acetate and a little more acetic acid. You notice I drew a single arrow. This is not equilibrium. When I add strong anything, it goes to completion. And it's the first time now we're going to need to make an ICF box. Okay? Initial change, final. And when you use an ice box, you have to use molarity or atmospheres. When we use an ICF box, we have to use moles. So to start with, I have 0.2 moles of that, and I have 0.5 moles of that. And don't forget, I also have 0.5 moles of this, because those were in the buffer. And now it's just stoichiometry, or limiting reactant. The H+ and the acetate, can you see that this is going to run out first, the H+? And I'll use up the same amount of the acetate, and I'll make the same amount of acetic acid. So I end up with 0, 0.3, and 0.7. Notice that I have a weak acid and its conjugate weak base. When I look at this final line, I say, what do I have? I have a buffer. Well, we decided buffers are easy, right? H+ is Ka, 0.8 times 10 to the minus 5. Okay, make sure you do acid over base, so 0.7 over 0.3. And we get 4.2 times 10 to the minus 5 molar H+. We take minus the log of that, we get a pH of 4.377. So the pH went from 4.745 to 4.377. Remember that the water went from 7 all the way down to 0.398. So buffers resist changes in pH. It's not that their pH doesn't change, it just doesn't change very much compared to, say, plain old water.